All right, guys, Mass 1700. I tell you, I have a meeting here in about 45 minutes, so we have to make this one pretty quick. So I'm going to go through some of these at Mach 4 speed. But this is, what, the fifth video I think we have on systems of linear equations and matrices, so we should be pretty good here. And I'll tell you what, I would highly recommend at this stage of the game is for you to pause the video. I've uploaded this handout to Blackboard. And so I would recommend that you go through these and try them and then compare my answers with yours. And hey, who knows? Maybe you'll be right and I'll be wrong. But maybe not. I don't know. So anyway, we got a problem here. I always go to the last sentence. What's the cost of a bowl of noodles and a carton of fresh milk? So I'm going to do X equals the cost of noodles, and Y is going to be the cost of milk. So I have two variables, two unknowns. So I see that the cost of 3 bowls of noodles and 2 cartons of fresh milk is 2153 yen. 3 cartons of fresh milk cost 89 cents more than a bowl of noodles. Now, the question here is, where do we add the 0.89? So 3 cartons of this cost 89 more than a bowl of noodles. Well, it's kind of the same logic we've done before, where we had to multiply the smaller. To make these two things equal, we have to add the 0.80, or well, the 89 to the smaller value. Because again, 3 cartons of fresh milk cost 89 cents more. So when we bring the equal sign in, we're making these two quantities equal, so we have to add to the smaller amount the 89. Next thing we need to do is get this thing in augmented matrix form. We need to get the X over here. The Y is there. And we have 89. So use our calculator to solve this. Gang, let's do this Mach 4 speed. So we have a 2 by 3 matrix, and we have a 3, a 2, and a 2153, and we have a -1, 3, and 89. -1, 3, 89. Okay? Quit. Go back into matrix. I'm going through this fast because we've already done a bunch of this. Go back into matrix, get the matrix, close it up, and we see that we have 571 yen for noodles and 220 yen for milk. So our question up here, what is the cost of a bowl of noodles and a carton of fresh milk? So if we add those, we get 791 yen. Okay? Easy stuff, guys. We need to be getting good at this stuff now. Grocery store finds a 2 friends. Use does not. What in the world is that? The grocery store, the 2 friends. Oh, okay. I don't like the grammar there, but the grocery store used by 2 friends does not mark prices on its good. One friend went to the store, bought some stuff. Another one bought some more stuff. Now they want to return some stuff. How much will be refunded? Well, it looks like they want to return a package of bacon and carton of milk. So let's let X be the packages of bacon and Y be cartons of eggs. All right, Two equations, we need two unknowns. One friend bought 3 bacons, 2 eggs, paid $7.45. Not knowing, the first friend went to the store, second friend went to the same store, purchased 2 bacons, 3 eggs, and paid $6.45. Guys, this is an easy one to put in the augmented matrix. So let's do it. You guys should be getting really good at these by now. So 32745 and 23645. All right, just like before, and we get $1.89 and 89 cents. So this is $1.89. This is 0.89. So the question is, now they want to return 2 of these and 2 cartons of eggs. So how much will they get back? And it looks like they get back $5.56. All right. Mach speed, guys. All right, number 3, a 6,000 to 7,000 pound yearling horse needs a bunch of calcium, a bunch of phosphorus. Farmer combines oats and molasses, rolled oats, calcium, phosphorus, bunch of words, don't really care yet. Let's go to the last sentence and see what we're going to solve for. How many pounds each of rolled oats and molasses? So I'm going to let X be pounds of rolled oats and Y be pounds of molasses. Okay. Set up a system. Well, we can see that we need so much calcium and so much phosphorus. So I'm going to set up an equation for my calcium. Well, we get a combination. Rolled oats provide 0.41 of calcium. And molasses, 3.35 of calcium from the molasses. We need a total calcium of 33. Next thing I'm going to do is I'm going to concentrate on the phosphorus. We need 21. We're going to get that from the 1.95 from the rolled oats and the 0.36 from the molasses. So this part right here gives us a rolled oats contribution, and this gives us our molasses, and this gives us our total of calcium and total of phosphorus. All right? I'm going to assume done. I'm just going to assume that we can do that. If not, you and I need to talk. All right, so 0.41, 3.35, and 33. Guys, just don't make a typo. It's frustrating to know what you're doing and to make a typo. 0.36 and 21. All right, second quit. Let's go back to our entry. We've got to go one more row. And we can see that we get 9.16 and 8.73. So 9.16 pounds of rolled oats and 8.73 pounds of molasses. All right. Makes it nice when things come out nice, 9, 8, but when we get into pounds and things like that, sometimes it doesn't. Okay. Number 4. This problem actually turned up on an exam. So now that I got your attention, painting, drying, polishing, centurion, tribune, senator, yada yada yada. I go to the last sentence. The company uses 240, yada yada yada. How many of each type of car is produced? 3 types of cars. So X is the number of centurions. Y is the number of tribune. Z is the number of senators. Guys, got 3 equations. We need to find 3 unknowns. Well, we know that we're going to have requiring painting, drying, and polishing. Each centurion requires so much painting, so much drying, and so much polishing. So we're going to have an equality for painting. We're going to have an equality for drying. And we're going to have an equality for polishing. All right, so let's circle things as we go. Painting, painting, and painting equals total painting. Go to drying. Drying plus drying plus drying equals total drying. Polishing. 1 hour polishing. 2 hours polishing. And 3 hours polishing. Polishing plus polishing plus polishing equals total polishing. So gang, our augmented matrix now we'll put this in our calculator, and guys, the answer to this problem has to be a number. Not that the previous wasn't a number, but this has to be a count, because we're doing numbers of cars. 5, 10, 12, 11, 13. It can't be 6.2. We can't have 6.2 cars. So we get an indication if we got it right or wrong based on our outputs. So we need to set up our matrix. Guys, we're going to have a big matrix here. It's going to be a 3 by 4. So 8, 10, 16, 240, 2, 3, 5, 69, and 1, 2, 3, 41. All right, probably got what we need. There it is. So we have 10, 8, and 5. And we're done. Number 5, in a survey of 1,000 college students, the following information was obtained. 500 were liberal arts and science majors, of which 50 were female, or I'm sorry, 50% were female. Express yada 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 in a 2x3 matrix. Well, this is interesting. I don't remember that. Label the rows as male and female. And the columns as LAS, ENG, and education. Okay, so we know first of all that all of the entries have to add up to 1,000. And we know that 500 were liberal arts and sciences and 50% were female. Well, that tells me that 50% also had to be male. 300 were engineering, 75% were male. So 225 were male. But this line right here, this column has to add up to 300, so that had to be 75. And the remaining were education majors. So what do we have? We have 500 plus 300 so far, so it's 800, so we have to have 200. This number and this number have to be 200. 60% of the 200, which is 120, have to be female, so we have to have 80 male education. I do not understand the purpose of that problem, but yeah, I don't know, whatever. All right, so B, C, what is the size of the matrix B times C plus C? Well, let's find, first of all, the matrix, the size BC. So B is a 3x3, C is a 3x2. These numbers are the same, means we can multiply them. The product is going to be a 3 times 2, 3x2. The only way we can add a matrix to this matrix once we take the product of it is if it's the same size. So 3x2. Now it says find the matrix. Well, I'm going to put in B and C, and I'm just going to put this in as it shows. I'm going to put in B. And B is a 3x3. So let's get this out of the way where I can see. So 104, 012, and 0, -1, 1. All right, going to C. Guys, remember C was a 3x2. So we have 3, 1, 4 -1, and 0, 2. Watch the typos, even I can make them. All right, gang, what we need then is we need B times C. Plus C. And you'll see we get a 3x2 just as we thought we would. All right, gang, this is the last question. Cool.
I'm going to make my meeting.
All right, Hilltop Motors has 2 dealerships, east and west. The inventory for its 3 most popular selling vehicles, SUVs, simply called A, B, and C at each dealership, is given in matrix M. So it looks like M We have east and west. In the inventory, we'll call the vehicles just A, B, and C. Okay, it says down here, doesn't it? So this is M. And the wholesale, we're going to call this matrix P. So the wholesale, retail, so this must be the wholesale and retail. And then the rows represent the models. Probably see where we're headed with this. Find M times P. So guys, M is a 2 by 3. P is a 3 by 2. So these numbers are the same, so we can multiply them. But the product only makes sense if the columns from the first matrix measures exactly the same thing as the rows of the second matrix. So it does. So we're going to have a 2 by 2 matrix, and its meaning is going to take the rows from the first matrix, the columns from the second matrix, and create this matrix. So this entry, for example, will be the wholesale price for dealership East, retail price for dealership East, and wholesale and retail for West. Okay? Now I'm going to go ahead and pop these in. I'm going to just go, I'm going to let this one be A and this one be B. So I'm going to go ahead and do this. So again, I need a 2 by 3. So 15, 22, 19, 17, 18, and 23. Quit. Go to B. 3 by 2. So we have 15,000. 22,000, 17,500, 26,100, 18,700, and 28,000. All right, gang, we need to multiply A times B. That should be a simple operation. So we have, wow, 965, 300, 1, 4, 3, 6, 200, 100, wow. Got to be careful writing these things down. So gang, it looks like the wholesale price of the cars at the West is a little bit over $1 million. Looks like it's slightly less by $965,300 at dealership West. If they sell all their inventory at the retail price, East is going to be 1.4 million, and it looks like the West is going to be close to 1.5 million. You could take these, take this row and subtract it. I'm sorry, this column and this column and subtract it. And you would get the profit, which is the retail minus the wholesale, at the West dealership. All right, gang, that's cool. I hope that helped. It should. If you played along with me, it should. Take care.